So in this example, we have a pretty ugly looking problem. And this is probably one of the rougher ones to doing a derivative when you don't have to do like a product rule or a quotient rule. It's just the power rule, but it doesn't look like that at all. So we need to somehow figure out how to do this derivative. And right now it is not at all derivative friendly. So we need to rewrite this in a bunch of different ways. And so we need to do we don't want radicals. That's part of it. And then we don't want variables in the denominator. That's another part of it. And then we have x's that we need to mix together. So there are a couple layers that we need to clean this up until it's ready to do the derivative. And then we'll do our derivative. So if I rewrite this, and the first thing is I don't want square roots, right? So I'm going to rewrite those as exponents. So I have a negative 6x to the sixth times, I could rewrite this as x to the 1/2. And then over here, I can take this value and bring it up, and I can take this x to the 1/2 and bring it up. So originally, I would have this, and then I would be bringing that stuff up before I'm ready to do the derivative. But there's a couple other things that we have to do here is I want to put this stuff together. I want to put that together, and I want to bring it up. So whatever I get when I mix this together, it's going to become a negative exponent. And then this is just going to be some sort of a fraction. So I need to add these exponents together. So it's going to be 6.5, but I don't want a mixed number. I want just a fraction, an improper fraction. So if I take 6 plus a half, I'm really taking 12 over 2 plus the half. So then that is going to simplify, if I mix that together, into a negative 6x to the 13 halves. And I'll bring that one up. So plus 6x. Those two are going to be 4 over 2 plus the 1 over 2 to get our common denominator. So you're looking at a 5 over 2. However, it came from the denominator. So that's going to be a negative 5 over 2. All right, that is derivative friendly. So once we get into that, look, we can do our derivative. And so that 13 halves is going to end up mixing and multiplying with this. So the 13 halves is going to come down. And then we're going to take and subtract 1 from it. And subtracting 1 is going to be subtracting a 2 over 2. So that's going to become an 11 halves. And then here we're going to bring the negative 5 halves down. And then we'll subtract 1. But if you're subtracting 1, you're going further into the negatives. So we're going to get a negative 7 over 2. All right, and then one last little bit of cleanup. We are going to leave these as rational kinds of answers. We may take this and kind of put that into the denominator, but we're going to do a little bit of cleanup. And that little bit of cleanup is going to be that 6 and that 2 can simplify. So that's going to be a 3, that's going to be a 1. So we're looking at negative 39 x to the 11 halves. And then here, this is going to be a negative 30 over 2, so negative 15 x to the negative 7 halves. So this is potentially one way to leave your answer. Okay, so it depends on what the directions are asking. So I'm going to do a little bit more cleanup just in case they ask for some other kinds of directions. So the other type of directions are going to be, we don't want negative exponents and we don't want rational, fractional kind of exponents. It's kind of based off of if your original problem looked like this, where you had radicals in it, we need to take our final answer and put radicals back into it. So if the directions are asking for something more like that, then we got to keep going. So if we keep on going, we would be looking to rewrite this as negative 39, and it's the square root of x to the 11th, right? Because your root is your radical, your denominator is your root, and then the numerator is your exponent. Now, if they're not okay with that because you have a whole lot of perfect squares, then we're going to need to simplify that piece as well. This one, we would have 15 over the square root of x to the 7th. And if you're not okay, so this is a potential second answer. But they may ask for everything. And that everything is, we have perfect squares, so we need to simplify this radical. So if we have that, we are looking to simplify this And we can take 5 groups. So like x to the 10th, you can rewrite that as an x to the 10th, and we would have left an x. So that would be x to the 5th, would be on the outside with a square root of x left over, right? Because we got 5 perfect squares that we can take out of that. And then here, that x to the 7th, we can write it as x to the 6th and have an x left over. So that would be x cubed. So minus 15 over x cubed square root of x. So if you have to do all the pieces to it, then that's really what you're looking for. So probably this one won't be okay, but it's either this is going to be okay or you got to do the full on simplification. So those are the 2 different potential looks. But very first thing is we got to get it derivative friendly no matter what, and then just apply our rules to it, and then just kind of look into the directions and how far do we need to take this.